Hello students, welcome to my online analytical chemistry tutorial. Now I'm going to solve one analysis problem in gravimetry. Here is the problem. The calcium in a 200.0 ml sample of a natural water was determined by precipitating the cation as calcium oxalate. The precipitate was filtered, washed, and ignited in a crucible with an empty mass of 26.6002 grams. The mass of the crucible plus calcium oxide was 26.7134 grams. Calculate the concentration of calcium in water in units of milligrams per 100 ml of water. To solve the problem, first we have to identify all given and what is asked in the problem. In this problem, we are given the volume of water used for analysis, and this is 200.0 ml. Also given the mass of empty crucible equal to 26.6002 grams, and after ignition, the mass of crucible and calcium oxide equal to 26.7134 grams. We are asked to solve for the concentration of calcium in water in milligrams per 100 ml. But before I solve the concentration of calcium in water, let me show you first the flow diagram of the analysis. This is our water sample. We add into our water sample oxalate ion. The purpose of adding oxalate ion is to precipitate the calcium ion in water as calcium oxalate. This is a white precipitate, okay? Okay, or I mean the color of this precipitate is white, okay? Now, what is the source of our oxalate ion? Usually, the source of oxalate ion is ammonium oxalate. Why ammonium oxalate? Okay, ammonium oxalate is used because ammonium oxalate readily precipitates calcium as calcium oxalate. When the precipitation is complete, we thoroughly wash our precipitate with distilled water. The purpose of washing is to eliminate completely all water soluble substances that might be present in our precipitate. Okay, so after washing, we oven dry our sample to completely remove water. And after drying, we burn our sample using a Bunsen burner flame. What is the purpose of burning our sample using Bunsen burner flame? The purpose is to burn the filter paper. Okay, so the filter paper is burned and converted into carbon dioxide gas. Now, after burning, we are not sure if all volatile substances are completely eliminated, so we ignite our sample in the furnace to convert this calcium oxalate to calcium oxide. Now, what do you think is the temperature setting of our furnace so that this calcium oxalate can be converted to calcium oxide? Now, the fact that calcium oxalate was converted to calcium oxide, then the temperature setting of our furnace is 1000 degrees Celsius. Okay, if we ignite calcium oxalate at a temperature only of between 500 to 600 degrees Celsius, this calcium oxalate is converted only to calcium carbonate. Okay? So the fact nga ang problem diri nag-mention nga ang finished product sa analysis is calcium oxide, then the temperature used is 1000 degrees Celsius. So after ignition, we cool our calcium oxalate in the desiccator, and then we measure the mass of crucible containing the calcium oxide, and that is equal to 26.7134 grams. Now, if we are going to subtract the mass of an empty crucible, the mass of calcium oxide is 0.1132. Now, we can solve for the concentration of calcium in water. So, to solve for the concentration of calcium in water, we have to use this formula. The concentration of calcium is mass of calcium in milligram unit divided by the volume of water in ml unit times 100 ml. So we have to solve first the mass of calcium. The mass of calcium is equal to the mass of calcium oxide times 1 mole of calcium per 1 mole of calcium oxide. But 1 mole of calcium oxide is equal to the formula weight of calcium oxide times 40.78 grams of calcium per 1 mole. This quantity here is the atomic weight of or the molar mass of calcium. Now substitute the value. The mass of calcium oxide is 0.1132 grams times 1 mole of calcium per 1 mole of calcium oxide, but this 1 mole of calcium oxide equal to 56.077 grams calcium oxide. So here we can calcium gram of calcium oxide. Then we multiply this by the molar mass of calcium, which is 40.078 grams calcium per 1 mole. So we can cancel mole calcium and mole calcium. The unit left here is gram calcium. Now, if we are going to simplify this, the answer is 0.0809 gram of calcium. Next, we calculate the concentration of calcium. This is equal to 0.0809 grams calcium over 200 ml of water times 100 ml water. Now, if we are going to cancel this ml unit, the unit left is gram calcium. The requirement is milligram calcium, so we multiply this by a factor of 1,000 milligram per 1 gram. So by multiplying, we convert gram calcium to milligram calcium. So simplifying, the answer is 40.45 milligram calcium per 100 ml water sample. So I hope my discussion is clear. So thank you for viewing or thank you for listening. Now, if you like this video, please like and share. So thank you very much.